Question 15 asks us to show that sin x minus sin x times cos 2x is approximately equal to 2x cubed for small values of x. We're going to need the small angle approximations for sin x and cos x, which are as follows. Using the approximations leaves us with the following. If we expand and then simplify, we get to the final result of 2x cubed.
Question 15b then says, hence show that the area between the graph with equation y equals the square root of 8 times sin x minus sin x cos 2x, the positive x-axis, and the line x equals 0.25 can be approximated by 2 to the m times 5 to the n, where m and n are integers to be found.
First, we recall the approximation from part A. Substituting the approximation in, simplifying. Next, we can split up the square root. Simplifying, the area can then be found with the following integral. We can take out a factor of 4. Integrating leaves us with the following.
Taking out a factor of 2/5 and substituting in the limits leaves us with the following.
Simplifying, we can now start writing everything as powers of 2 and as powers of 5. Combining the powers of 5 leaves us with our final answer.
C part 1 asks us to explain why the integral from 6.3 to 6.4 of 2x cubed dx is not a suitable approximation for the integral from 6.3 to 6.4 of sin x minus sin x cos 2x dx. We cannot use the approximation because the limits are too large. The approximation from part A is only valid for values close to 0.
C part 2 then asks for us to choose suitable values of a and b such that we can use the approximation from part A. First, we note the sine function in our integral repeats every 2 pi, and the cos 2x repeats every pi. This means we can subtract 2 pi from both limits and the integral will still have the same value. This allows us to now use the approximation as the new limits are close to 0.